Hello student, welcome back to lecture series on numerical methods. So in my today's video guys, I'm gonna explain to you all Gauss-Jacobi method, okay, which is helpful for finding the solution for linear equation in a 3 variables. Okay, so mostly you will get the 3 variable in your question paper as x1, x2, x3. So that I'll prefer you all to solve the example using x1, x2, x3 so that you cannot get the confused while in your exam. Okay. Yes, so let's get down into our today's lecture guys. Okay, so in my today's lecture video, I'm gonna explain to you all Gauss-Jacobi method only. Okay, so and next lecture we go for example based on the Gauss-Jacobi method. Okay, yes, so what actually Gauss-Jacobi method says? That the Gauss-Jacobi method says that for finding the solution of a linear equation in a 3 variable. Okay, so we consider some assumption. Okay, so let me explain this assumption. Okay, linear equation in a 3 variable. Okay, consider the equation. So we want this equation for finding the solution. Okay, this is just overview for the method. Okay, that you can understand. Okay, yes, consider the equation. Consider the equation. Consider the equation. So let me consider equation, a linear equation in 3 variable. A times x1 plus b times x2 plus c times x3, which is equal to d. Okay, d1. Okay, consider d1. Okay, a times x1, b times x2 plus c times x3, which is equal to d1. Another second equation. So consider a1 here, so we can change the variable a1 x1 plus b1 x2 plus c1 x3, which is equal to d1. Another linear equation in a 3 variable a2 x1 plus b2 x2 plus c3 x3, which is equal to d2. Okay, and third linear equation a3 x1 plus b3 x2 plus this one is a C2 guys. Okay, a3 x1 b3 x2 plus c3 x3, which is equal to d3. Okay, so I consider these 3 linear equation. Okay, so just for your understanding, I consider here as a variable, but now we can see a1 b1 c1 d1, a2 b2 c2 d2, a3 b3 c3 d3, all are constant. Okay, these represent the constant values. Okay, and unknown variable x1 x2 x3 are the unknown variable. This one x1 x2 x3 and x1 x2 x3. Okay, these 3 are the unknown variable. Okay, and constant a1 b1 c1 d1. Okay, a2 b2 c2 d2 and a3 b3 c3 d3. Okay, so this is the constant and variable. Okay, so these are the linear equation in a 3 variable. So what is our task here? Okay, what is our claim? Our claim is here to find out the value for x1. Our claim is here to find out the value for x1, x2 and x3. We want these 3 values over here. Okay, this is our task. Now it is one of the easy method guys in numerical methods. Okay, it is one of the easy method and can give us the very easy solution. Okay, now let's what we do. We are going to find out the value for x1 using this method, using this equation. We are going to find out the x2 using this equation, and we are going to find out the x3 using this equation. Okay, now see carefully how I am going to find the value for x1 x2 x3. So x1 can be written as, take a1 to the other side, so it gives us the 1 upon a1. So remaining all the terms we want it to the other side. Okay, so d1 minus b1 x2 minus c1 x3. Okay, this one is the x1. Again similarly x2, like x2 1 upon b2 under bracket d2 minus a2 x1 minus c2 x3. This one is the x1, this one is x2. Okay, so using second equation I found the value for x2. Using first equation you can go for the x1. Okay, similarly do it for third equation. Okay, I want the value for x3 now. Okay, so what you can write x3 as 1 upon c3 Okay, 1 upon c3, that means the variable and constant each along with x3 over here, I'm taking it to the other side. Okay, so x3 can be written as 1 upon c3 d3 minus a3 x1 minus b3 x2. Okay, so this one is our value for x1, x2, x3 using these equations I found here. Okay, yes, now see that. So we have to start the iteration. Okay, we have to start the iteration using the some initial assumptions. Okay, so what assumption we needed here? We consider x1, x2, x3 all need to be a 0, but not this one. Okay, we want this to be alive. Okay, so that we consider this one, this one, this one as a 0. Okay, so first iteration, what first iteration says? What first iteration says that? Consider x1, x2, x3 which is a 0 for this side. Okay, not for this one. So consider x which is equal to x1 which is equal to x2 which is equal to x3 is a 0. Okay, so what our first iteration? First iteration say that take its the power 0. So x1 to the power 0, x2 to the power 0 and x3 to the power 0. This one is our first iteration. Okay, so 1 upon a1 keep as it is, 1 upon b2 also keep as it is, 1 upon c3 also keep as it is. Okay, under bracket what we have? We consider x1, x2, x3 0 for our first iteration. Okay, so d1 can be 0 as we don't have x1, x2, x3 here. d2 also it can be 0 and d3 also. Okay, so d1, d2 and d3. Okay, yes. Now see that if x2 0, this goes to 0, x3 0, this goes to 0. If x1 0, this one gives us 0, x3 0, this one gives us 0. Okay, if x1 0, x2 0, all these two terms goes to 0. Okay, so this one is our required answer. Okay, first iteration say that x1 to the power 0 as 1 upon a1 d1, x2 to the power 0 1 upon b2 d2 and x3 to the power 0 1 upon c3 d3. Okay, this one is our first iteration. Similar repeat second iteration. Okay, second iteration. Second iteration, what it is says that take its power 1, x1 to the power 1, x2 to the power 1, x3 to the power 1. Okay, and the another x2, x3, x1, x3, x1, x2 take their power as 0. Okay, so how I'm going to write 1 upon a1, it is here under bracket d1 minus b1 x2 to the power 0, d1 minus b1 x2 to the power 0 minus c1 x3 to the power 0. So I'm going to take their power 0 here, power 0 here, power 0. Why power 0? Because I want this power 0 here in this equation so that we can get the value x1 to the power 0, x2 to the power 0 and x3 to the power 0. Okay, so 1 upon b2, next d2 minus a2 x1 to the power 0, d2 minus a2 x1 to the power 0 minus c2 x3 to the power 0, and 1 upon c3 d3 a3 x1 to the power 0, d3 minus a3 x1 to the power 0 minus b3 x2 to the power 0. Okay, now see that I got the value for x1 dash, x2 dash and x3 dash over here. Okay, so what is our task? Replace x1 to the power 0, x2 to the power 0, x3 to the power 0 everywhere in this equation inequality. You will get the x1 to the power 1, x2 to the power 1, x3 to the power 1. Okay, and similar you have to repeat the iteration. Okay, now third iteration what it is says that as power 1 take x to the power x1 to the power 2, x2 to the power 2, x3 to the power 2. Okay, which is equal to 1 upon a1 as it is, 1 upon b1 as it is, 1 upon b2 as it is, and 1 upon c3 as it is. Okay, so this 1 upon a1, 1 upon b2, 1 upon c3 I am keeping as it is. Under bracket what we get here, now see that as we have x1 to the power 1, x2 to the power 1, x3 to the power 1, So replace x2 as x2 to the power 1, x3 as x3 to the power 1, okay, all are power to the power 1, okay. So what we get, d1 d2 d3 minus b1 x2 to the power 1, okay, minus c1 x3 to the power 1, okay, under bracket, minus a2 x1 to the power 1 minus a2 x3 to the power 1 minus a3 x1 to the power 1 minus b3 x2 to the power 1, okay. This one is the third iteration. Find out the value. Again similarly go for the fourth iteration, x1 to the power 3, x2 to the power 3, x3 to the power 3, okay. This one is your fourth iteration, and repeat similar iteration. But how many times we have to repeat similar iteration? So you all are having similar question, okay. Yes, so until and unless we do not get subsequent iteration quite closer, okay. Now see that x1 to the power 1 and x1 to the power 2, if their two values are very much closer, again x2 to the power 1, x2 to the power 2, their values also very much closer, and x3 to the power 1 and x3 to the power 2, okay, their value, that means their difference, it is like a negligible, very much less difference between the two terms, okay. That means these two iteration are approximately closed. It's not that necessarily second and third iteration can give us the value. Maybe you have to find out the iteration like a fifth iteration, sixth iteration, seventh iteration, but make sure that look out for the values, where we have subsequent iteration. Subsequent iteration means after this one you have to take this one, okay, and check their subsequent values only, okay. So don't take first iteration with the third iteration, that one is wrong, okay. So we want the similar iteration from second, third, fourth, fifth and so on, okay. So this one is our, and at the end the similar value you will get now. These are the required x1, x2, x3 for your given linear equation in a 3 variable, okay. So I hope you all have understood Gauss-Jacobi method. It is one of the easy method, guys. It's not that difficult, okay. So see that how easily we replace the x1, x2, x3 0, then just need to find out the values, okay. One of the easy method, and definitely you will get this question in your SPPU question paper for 5 marks. Every year I found similar questions, okay. So get it properly prepared. This one is very much important concept, okay. So I hope you all have understood, guys, my today's lecture. So if you want, you can note it down my notes. This one will be the helpful for understanding the concept, okay. So even after, if you found anything difficult, guys, let me know in my comment section, okay. And if you want anything more videos similar like this, let me know in my comment section, guys, okay. Or you can reach me. So I will help you all to understand the concept. I will upload the similar concept and doubt here in my channel, okay. So that's it for my today's lecture, guys. I hope you all have understood everything. So thank you everyone. Thank you for my today's lecture.